This is the second video on organic compounds with polyfunctional groups. If you observe this particular example, in this example we have ester functional group and ketone functional group. According to IUPAC sequence rule, ester functional group gets more priority over ketone functional group. Therefore, numbering should be started from this position: 1, 2, 3, 4, 5 and 6. Here the carbon of this ester cannot be taken into the longest chain. Therefore, here we have to use a special suffix carboxylate. That is point number 1. While naming esters, irrespective of alphabetical order, alkyl group attached to oxygen should be indicated first. That is point number 2. And here this is not functional group. Here this is a second grade functional group. It is named by using prefix part, and here the name of this particular group is ethanoyl. Acetyl is also accepted. Ethanoyl is more systematic. Combining all these things, you will get the correct name. So that is ethyl 4-ethanoyl benzene carboxylate. Ethyl 4-ethanoyl benzene carboxylate. Now let us move on to the next example. Here we have carboxylic acid. At this position we have a CCl3. It is not a CH3, CCl3. So this is actually one carbon substituent methyl, but this is a trichloromethyl. Trichloromethyl, numbering must be from this carbon. First carbon, second carbon, third. Of course, remaining carbons are like this. And this is a complex substituent and its name should be enclosed in brackets. At third position, we have trichloromethyl benzene carboxylic acid. It is a chain terminating functional group. It is directly attached to the ring system. The name of this carbon could not be adjusted in the longest chain. Therefore, we have to use the special suffix benzene carboxylic acid. And let us move on to the next example. Here, this is the compound. You just observe, you search for the functional groups first. So here we have OH, here we have NH2. Now you apply sequence rule. OH and NH2, without any hesitation, alcohol receives more priority. Therefore, this is the first carbon, this is the second carbon, and after that this is the third carbon, this is the fourth carbon, this is the fifth carbon, and this is the sixth carbon. So this is the longest chain of this particular organic compound, 6 carbons. And here this is branch, this is also branch. Prefix name we have to use. Prefix name of NH2 is amino. This is ethyl, only alphabetical order. So 5 amino, 3 ethyl, hexane, 2 ol. Now let us observe this example. You just search for the functional group. Here you have aldehyde functional group. Here you have ketone functional group. Functional group, that is aldehyde carbon, it receives first priority. First carbon, second carbon, third carbon, fourth carbon, fifth carbon and sixth carbon. This is the longest chain. Why this is the longest chain? Why not other? You just think. Here this is branch, name is ethyl, branch, name is ethyl, branch, NO2, nitro, and this is oxo, only alphabetical order. So here ethyl, even though we are saying diethyl, that D should not be considered, only ethyl we have to consider. This is ethyl, this is oxo, this is nitro, only alphabetical order. So 2, 4 diethyl, 3 nitro, 5 oxo, hexane all. So here up to here, this is a prefix, this is root word, primary suffix and secondary suffix. And let us observe the next example. Carboxylic acid we have nitrile functional group, alcohol functional group. According to IUPAC sequence rule, carboxylic acid receives first priority, second carbon, third carbon, fourth carbon, fifth and sixth. Now, if you see the branches in this, this is one branch, this is one branch, and this is another branch. Prefix names we have to use. Prefixes are always according to alphabetical order. It is ethyl, cyano, hydroxy. Only alphabetical order we have to follow. So this is 2 cyano, 4 ethyl, 6 hydroxy, hexane, oic acid. Observe carefully, this carbon is the part of the longest chain, so no special suffix, oic acid is correct. 2 cyano, 4 ethyl, 6 hydroxy, hexanoic acid. Now, we have ester functional group, this is ketone, and this carbon, first carbon, second carbon, third carbon, fourth carbon, and this is ethyl group, and this is oxygen of ketone. These are the two prefixes we have to use. While naming esters, alkyl group attached to oxygen should be indicated first. Ethyl 3-oxo-butanoate. You can see the name will be ethyl 3-oxo-butanoate. Now let us move on to the next example. So this is acid halide, and there is, so here this is a methoxy group. Here we have to use the primary suffix, primary suffix, primary suffix. Only acid halide is the functional group. A double bond and a triple bond, however, they are not in competition with acid halide, because for acid halides we use the secondary suffix. So this is the first carbon, second carbon, third, fourth, fifth, sixth, seventh and eighth. So the prefix is 8-methoxy, root word oct, 4-6-diene, 2-ine, oil chloride. So here this is double bond ene, it is triple bond ine according to alphabetical order. En, yn, en comes first. Let me repeat. 8-methoxy, oct, 4-6-diene, 2-ine, oil chloride. You can see the name. So here E and this is Y. Don't compare this D. Okay, this is E and this is Y. This is only numerical prefix to indicate the repetition, that should not be included in alphabetization. And here no special suffix, it is just oil chloride, because that carbon is already in the longest chain. You are covering this carbon in the form of root word. And let us move on to the next example. Here you have one ketone, here you have one ketone. First priority, first you need to consider ketone functional groups. If you start numbering from left side, one ketone, this is 2, 3, 4, 5, 2 comma 5, 1, 2, 3. So definitely here we are saying 2, here we are saying 3. If you give from right side, definitely numbering must be from left side. So this is first carbon, second carbon, third, fourth, fifth, sixth and seventh. There is no prefix, straight away root word hept. 7 carbons hept, 3-6-diene, 2-5 dione. Diene, dione. Root word is hept. There is no prefix. Now let us move on to the next example. So whenever organic compound is given, the first step you have to do, identify the functional groups. Here we have amide functional group, triple bond, double bond. But however, here we are giving secondary suffix, but here primary suffix. So need not to compare these two, because however, even if you compare, secondary suffix will get more priority. And this is branch substituent, this is also substituent. So the numbering will be like this: longest chain and numbering. This is first carbon, second carbon, third, fourth, fifth, sixth, seventh, eighth and ninth. Totally there are 9 carbon atoms. Root word from that you can get. Now you identify the substituents. So here this is methoxy, this is ethyl, this is also ethyl. In order to indicate the names of the substituents, we have to use prefixes, and while writing the names of prefixes, you have to depend only on alphabetical order. So the name of this group is ethyl, the name of this group is methoxy, and in alphabetical order, ethyl comes first. So 2,7 diethyl, 4 methoxy, non 8 ene, 5 ine, amide. En and ine are in competition. Here it is En, this is Yn, En comes first. You can observe the name. So here ethyl, methoxy, root word, primary suffixes, secondary suffixes. So no special suffix because that carbon is included in the longest chain. This is the compound. Let us move little fast. Ester functional group 1, 2, 3, 4. While naming esters, irrespective of alphabetical order, alkyl group attached to oxygen should be indicated first. Therefore, it is ethyl 3-hydroxy but 2-ene O8. And in the next example, if you identify the functional group, here it is aldehyde we have, cyanide we have. According to sequence rule, cyanide nitrile functional group receives more priority. So this is the first carbon, second, third, fourth. I'm moving left side because I will get more number of carbons. This is the 5 and this is the 6. Now the branches are substituents. So here this is aldehyde group and this is ethyl group, and here this is oxygen. You already know when aldehyde group is present as substituent, prefix we have to use. Two options you have. One we have to say formyl, another one we have to say oxo. So this carbon could not be adjusted in the longest chain, therefore we have to say formyl, and this carbon is adjusted in the longest chain, therefore we have to say oxo. So prefixes are ethyl, formyl, oxo, only alphabetical order. So 2 ethyl, 4 formyl, 6 oxo, hexane, nitrile. So no special suffix because that carbon is included in the longest chain. So instead of saying carbonitrile, we have to say nitrile. You can observe the name properly. So alphabetical order E, F, O. Here one is formyl, another one is oxo. Observe carefully. And in the next example, we have carboxylic acid, carboxylic acid, carboxylic acid. More than 2 chain terminating functional groups are present. We have to use the special rules. So the principal carbon chain, so this is first carbon, this is the second carbon, and this is the third carbon. So this is the principal carbon chain. Of course, you can start numbering from this side also. Special rule you have to use, understand the special rule, then solve this question. So more than 2 identical chain terminating functional groups and all of them are directly attached to the principal carbon chain. Therefore, carbon of that chain terminating functional group should not be taken into the longest chain. We have to use the special suffixes. So now this is hydroxy located at a second place. Therefore, it is 2-hydroxy propane 1 comma 2 comma 3 tricarboxylic acid. Special suffix we have to use. So root word, this is the longest chain. You can start numbering from this side also, there is no issue. And let us move on to the next example. Here we have aldehyde, here you have ketone, here you have alcohol. So there are two chains actually, closed chain, open chain. But the open chain has the functional groups, therefore this is the principal carbon chain and this is the branch. Aldehyde receives more priority. So this is the first carbon, this is the second carbon, this is the third carbon, this is the fourth, and this is hydroxy, and this is cyclopropyl, and this is oxo. Only alphabetical order. Prefixes are always arranged according to alphabetical order. So this is hydroxy, this is cyclopropyl, this is oxo according to alphabetical order. If you arrange the prefixes, you will get the name like 3-cyclopropyl, 4-hydroxy, 2-oxo, butanol. Cyclopropyl, hydroxy, oxo, chain terminating functional group, aldehyde, need not to indicate the position. And in the next example, here you have closed chain, here you have open chain, but open chain has the functional groups, therefore this will be the principal carbon chain. It may not be the longest because here you have 6 carbons, but still here you have functional groups. And this is the first carbon, this is the second, third, fourth, fifth, sixth, and this is a branch. This is branch. We have to use a prefix for this. We have to use prefix. Now, totally in this is located at fourth place. In that cyclohexyl at second position there is methyl. So first this total complex substituent is present at fourth place, therefore it is 4 2-methyl cyclohexyl but 2-ene-oic acid. That is the correct IUPAC name. 4, you can see this is at the fourth place of the principal carbon chain. 2-methyl cyclohexyl, root word but, 2-ene-oic acid. And here this is alcohol functional group. We have to use a secondary suffix. Here we have to use a primary suffix. Secondary suffix and primary suffix, always a secondary suffix gets more priority. Based on that particular rule, the numbering will be from this. After that, this is primary suffix, this is secondary prefix. Primary suffix, secondary prefix, primary suffix gets more priority. Therefore, this is the correct numbering of the compound. Clearly understand the rules, then you apply, there will be no error then. So this is a prefix located at 6th place, therefore it is 6-ethyl cyclohex 2-ene-1-ol. Understand the rules properly. Next, so here chain terminating functional group directly attached to the ring system like this. So this is branch located at the second place, 2-ethyl cyclohexane 1-carbaldehyde. So this is the name of the compound. Now you have amide functional group directly attached to the ring system, first carbon, second, third, fourth, fifth and sixth. Methyl, ethyl, alphabetical order, they are prefixes. 4-ethyl, 2-methyl cyclohexane carboxamide. Here you have ester functional group. So this is the first carbon, second, third, fourth, fifth. So this should be indicated first. So methyl 2,3 dimethyl cyclopentane 1 carboxylate. You just observe the name. Next we have two functional groups, one is alcohol and ketone. Ketone receives more priority, first carbon, second, third. 3 hydroxy cyclohexane 1 one. Next, here we have two chains. This is one chain, this is another chain, but in this chain there is a functional group, therefore this is a principal carbon chain. If you start numbering from this place 1 2 3, from this place 1 2 3, alcohol is receiving same priority, therefore I am considering this particular prefix. So this is the first carbon, second, third, fourth, fifth, and this is the branch. In that branch, this is the point of attachment 1 2 3 4 5. So here at second place there is a complex substituent. In that substituent is methyl. So 2, this is this point of attachment, this is the principal carbon chain at second place. 2 3 methyl cyclopentyl pentane 3 ol. If you are getting confused between these 2 and 3, so this is the principal carbon chain, this is attached to second carbon, and in this complex substituent from the point of attachment at the third carbon there is a methyl group. Understand the rules, every time I will say the same thing. And next we have ketone and alcohol. So here this is one chain, this is another chain, but a functional group is present here, secondary suffix is present here. So if you start numbering from this position 1 2 3 4, 1 2 3, ketone should receive least possible number. So this is the first carbon, second carbon, third, fourth, fifth, sixth, and this is the complex substituent, point of attachment like this. There is a double bond between second and third, cyclohexenyl, not cyclohexyl, cyclohexenyl. So this name begins with the cyclo C, this is a hydroxy, alphabetical order. At the fifth place there is cyclohexenyl, but that double bond position has to be indicated. Therefore that is a 5 cyclohex 2 in 2 in yl 4 hydroxy hexane 3 one. So cyclohex, this 2 is indicating double bond position, 4 hydroxy and a root word 3 one. And in the next example, carboxylic acid, no doubt this is first priority. This is a prefix, this is a prefix, this is a suffix. Prefix and primary suffix, no doubt primary suffix should get a priority. Why? Only in anti-clockwise direction. You pause the video, think and come to one conclusion. So I don't want to waste the time like this. So this is hydroxy H, this is cyano C, alphabetical order. So 5 cyano, 3 hydroxy, cyclohex 2 in 1 carboxylic acid. So 5 cyano, 3 hydroxy, cyclohex 2 in 1 carboxylic acid. In the next example, cyanide, amine, aldehyde, cyanide should get the priority. So here, no doubt this is the longest chain. However, cyanides are getting same numbering 1 and 4. You move like this or like this, cyanides are not getting affected. And here this is NH2, this is formyl. If you move like this, these are receiving 2 and 3. Even if you move like this, these are receiving 2 and 3. Least locant rule is unable to decide, therefore I am considering alphabetical order. Its name is amino A, formyl F, alphabetical order. So here this is the first carbon, second carbon, third carbon, fourth carbon. So 2 amino, 3-formyl butane 1,4 dinitrile. 2-amino 3-formyl butane 1,4 dinitrile. And here this is the first carbon, this is the second carbon, here we have chlorines, and here this is a phenyl group. So the name of this compound 1 comma 1 trichloro 2 comma 2 diphenyl ethane.